All right, this is still inverses, but it's verifying inverses. How do we determine if two functions are inverses of one another? And there's ways to do it graphically and algebraically. So graphically, what did we learn in lesson 1 about something like this? Do these two look like they're inverses? It looks okay. So we're going to say yes. Okay, they appear to be reflected over y equal x. And they also do what? What's the other way we can tell? Intersect on y equals x. Okay, so they intersect on y equal x. And that's not written very well, so let me try to rewrite that. Okay. So that's one way you can tell. Let's look at the next, these two, and we're going to see if they're inverses by graphing. And we're going to follow the trend that we set. We're going to make this one the end. We're going to treat that one like it's possibly an inverse, and this like it's our original function. So we're going to graph in pink and green. We're going to go ahead and put in the y equals x line so we can have something sort of as a reference. Put that diagonal line in. That's your y equals x. Again, remember. So when we graph 1/3 x plus 2, you go plus 2, and your slope is going to be up 1 and over 3. Okay. And down 1 and over 3. I'm not having a lot of luck. Okay. All right, now let's see if I can draw a straight line in. Now let's... Huh? I didn't mean to have it. Let me take that off and make it not dotted. Okay. All right. I think that's pretty good. All right, now the next one is -2. And so we're going to go down -2, and we have a slope of 3, 1, 2, 3, 1. Okay, then we're going to try to draw that one in. Okay, start there, draw it in. Okay, now where do these lines intersect? Are they inverses? We can't remember, lines are hard to tell a reflection, so we mostly look at the intersection. Are they going to be inverses? No, they're not. These are not inverses because they don't intersect . They don't intersect on y equal x. Okay, so those are not. So that's one way you can tell. And another way you could tell is to read some points. But if you have them on the same graph, it's easy because you can just tell where they intersect. But if you have them on separate graphs like the problem I gave you before, find some points. All right, now looking at the next one, there's a way to do this algebraically. And so that's what we're going to try to do now. Now this is what we do is we compose functions. And I think there's a piece of the notes that are missing. F, you want to compose f with g of x and get x. And you want to compose g with f of x. And that should also equal x. And I'm going to use highlighters a lot for this. But what that means is you're going to put g of x into f of x, and the other way you're putting f of x into g of x. Yes? So, what we're going to do, okay, I'm going to try to, we're going to first do f of g of x, okay, and what that means, let me get the color coding going here. This is f of x, and this is g of x, okay. So g of x is inside, and f of x is what we start with, okay. So that looks like this. F of x is 2, and then you don't put the x in there, you put plus 4. Okay, so here's our f of x. In where the x would normally be, that's where you put your g of x. So you put in the parentheses 1/2 x minus 2. And so hopefully you can see what I mean by putting g of x into f of x. Okay? And so then you just do the math. Once you do that, what is 2 times 1/2? It's just 1, so that's going to be x. 2 times negative 2 is minus 4 plus 4. Those add to be 0, and so when I compose these functions and put one into the other, my answer is x. And that's what you want to get. If they're inverses of each other, you're going to get x. But now we have to do it the other way. If it's ever not x, you can quit with one time. But if it is x, you have to go ahead and check it both ways. So now we're going to start with g of x. So we're going to start with g, and we're going to put f of x into g. So we're going to start with 1/2 x. Now instead of x, remember we're going to put f in there, minus 2. So here's our g. And inside that, we're going to put our f. And so what is f? 2x plus 4. Okay. So we put f of x into g of x. And so when we do our math, 1/2 times 2 is x. 1/2 times 4 is 2. And you still have your minus 2 out there. And so the answer here, again, is x. And when I compose them both ways and end up with x, then yes, they are inverses of one another. Okay. Now I'm going to do number 4 without the colors. Okay, so let's look at number 4. First, we're going to put g of x into f of x. So we start out showing that that's what we're doing. Put g of x into f of x. So our f, we start with that. We have 4x plus 3. And instead of x, what do we put in there? What the g, which is 1/4 x minus 3, right? Multiply 4 times 1/4 and you get x. 4 times 3 is negative 12 plus 3. And so we end up with x minus 9. Is that what we are supposed to end up with? No. Okay, that is not x. If we didn't end up with x, our answer is that these are not inverse functions. Okay, so these are not inverses. And once you end up with not getting x the first time, there's no point in checking it again, because I know if they don't both turn out to be x, that they're not inverses. So that one we could do with just one check. All right, looking at this one, I had a space where the graph ran off the page somehow on my picture. I don't know if it did on yours. But when you check these, it says to check them and graph them. So let's go ahead and put them on the graph. 3x plus 6, so 1, 2, 3, 4, 5, 6, put a dot. Slope of 3. Okay, and I'm going to draw in that line. Okay. And then my other one is 1/3 x minus 2. So we go to minus 2 and a slope of 1/3. Okay, and draw the line. Okay, and is our prediction that these two are going to be inverses, just from the graph? Yes, we think that they will be inverses. Now, how do we check it algebraically? Okay. Go back and to check if our instructions are to check it algebraically and graphically. We're going to do f of g of x. And so that's going to be 3. And what do we put in the parentheses? 1/3 x minus 2. And then we still have our plus 6. So 3 times 1/3 is x minus 6 plus 6. Does it look like they are going to check out? The first composition was good, wasn't it? Need it to be x. Let's look at the second one. We're going to put f of x into g of x. So we have 1/3 x minus 2, and instead of x we put in 3x plus 6. Okay, let me finish this last one. And that ends up with being x plus 2 minus 2, which is x. And so, both algebraically and graphically, this one checks out that these two are inverses of one another. Okay, that's all of 1-2. Are there any questions on